Hello everyone, my name is Subhashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions, and today I welcome you all to this special webinar. And today's topic is a very interesting one, that is the IPv6 routing on Cisco devices. So if you want to master the IPv6 and the routing you have to perform, say on the Cisco routers, on the Cisco devices, then how to do the IPv6 routing? And what is the need for IPv6 over the IPv4? All these things we have to discuss. So let's begin. So let's say this is a router and the switch. So let's explore what is the implementation and configuration of IPv6 routing on Cisco networking devices like the router and switches or firewalls. You have to understand the IPv6, that is the next generation of internet protocol, because IPv6 is the latest iteration of the internet protocol, and it is engineered to overcome the limitations of its predecessor like the IPv4. Like, what are the limitations? Like the IPv4 is 32-bit long address space, and let's say the IPv4 is binary, and it has limitation like 32-bit address space, means it is not having too much addresses, like few billions of addresses are left nowadays. So definitely you need to have a larger address space, and that is why IPv6 came. It not only offers a significantly larger address space, but it accommodates the growing number of internet connected devices, because nowadays the internet is growing very much, and that is why you have to accommodate all the devices. Say you have 10 smartphones, so definitely you have to have the IPv6 addresses for the smartphones. And also it includes enhancements in routing and network configuration capabilities. Also your routing is also growing, your BGP prefixes or the NLRIs, that is also growing. So this evolution is essential for the future of internet connectivity. So that is why a larger address space is there. And as we know that in IPv6 there is no class concept, there is no such public and private IP, although there is a private IP like unique local, link local, and the public IP in the form of the global unicast. But you do not say that way, like this is private IP, that is public IP. No, you do not have NATPAD there. So these are the differences between the IPv4 and v6. Now, the significance of IPv6 routing, it is unlimited address space that I was telling you. IPv6 routing overcomes the IPv4 address exhaustion, and this is vital for supporting the growing number of internet connected devices globally. Enhanced security features also it has. With enhanced security features built into its framework, the IPv6 routing helps to protect data integrity and privacy, and it also helps the networks more secure. Like it supports IPsec, Internet Protocol Security, and that is mandatory in IPv6, not an optional like in IPv4. So definitely is more secure than the IPv4 counterparts. Then you have improved network efficiency. Like IPv6 routing increases network efficiency through simplified packet headers and let's say the improved routing algorithms, and it means faster processing speeds and reduced overhead. Then comes the Cisco routers, the IPv6 powerhouses. So your Cisco routers are inbuilt with the IPv6 iOS, and all of them are designed to manage traffic between different networks and are equipped with advanced routing protocols. And they offer robust IPv6 support, makes them ideal for directing data across different networks. So nowadays, the routers are all supported with iOS, that is supports the IPv6. The days are gone where only the routers supported the IPv4. And also the Cisco switches, they primarily operate at the data link layer, connecting devices in the same network. Also, while they support some IPv6 features, their main purpose is within the LAN. So we know that the switch is a data link layer device, is a layer 2 device, it's within the LAN, but definitely it can have some IP addresses, because if you are creating VLANs, then definitely you have to give some IP address to the switch. And in that purpose, say the switch also supports IPv6 address. Let's come to the configuration of the IPv6 routing on Cisco devices. First, you have to enable the IPv6 routing. IPv6 routing enable is the first step in configuration process, and it can be done with the command IPv6 unicast routing. This is a single command you have to do. And although the iOS has features in it, but IPv6 routing is disabled by default. You have to enable it. If this command is not taking in any router, then no, you cannot do IPv6 on that. Then the configure interfaces, that is the second part. The configure interface for IPv6 requires assigning IPv6 address to each interface using which command? The command is IPv6 address. Then you give the address and the prefix, that is a /64 or /128. That is the prefix in the IPv6 we use in interface configuration mode. And it ensures that each interface can communicate over IPv6. Then third step, set up routing protocols. If you want to do static routing, do that. Otherwise, you set up the routing protocols. And set up routing protocols is essential for routing IPv6 traffic, as you know. And this includes the configuring protocols such as the OSPFv3, or let's say the EIGRP for IPv6, or even BGP version 6, which help in dynamically learning routes and thus ensuring efficient data transmission. Now, the static versus the dynamic IPv6 routing. What are the key differences between the static and the dynamic IPv6 routing? Now, static routing requires manual configuration of routes, offering, say, the precise control over the paths the data takes. And on contrast, the dynamic routing protocol leverages protocols that automatically update routing tables. So it is just like the IPv4. Nothing separate between the static and dynamic routing as per the, say, the routing is concerned. So the IPv4 and IPv6 is same. There is not much difference, but yes, it can support a lot more network prefixes. That is a part in the IPv6. And each routing method has unique benefits, like the static routing is beneficial, as we know, for the small and stable networks, while dynamic routing is ideal for larger, more complex environments. Then the key routing protocols for IPv6, let's come to the OSPFv3, that is the OSPF supported IPv6. Now, OSPF version 3 is a link state routing protocol, as we know, and it is designed specially for IPv6. So, like the IPv4 supported OSPF, OSPFv2, the v3 is also the, say, the link state routing protocol, and it allows for efficient routing and scalable network design by utilizing the areas and providing fast convergence times, because the OSPF, as we know, it is divided into different areas. Then let's come to the EIGRP for IPv6 features. EIGRP for IPv6 is a distance vector routing protocol, or rather an advanced distance vector routing protocol that combines the features of link state as well as with the distance vector protocols, as we know. And it provides a rapid convergence, and it is easier to configure than OSPF. And also the BGP, Border Gateway Protocol for IPv6. So BGP is a protocol used to exchange a routing information, let's say, between different autonomous systems on the internet, because it is an internet backbone protocol you have. And the BGP supports IPv6 and is essential for internet-wide routing and policy-based routing. So all these things, like the BGP, as you know, that millions of routes or NLRIs, network prefixes, are supported via the BGP. So that is why it is a protocol for the internet, not the OSPF or the EIGRP, because they are the enterprise routing protocols. So definitely the IPv6 support should be there, because otherwise you couldn't support all those NLRIs. Then what is the timeline of OSPFv3 configuration? Step 1, what you need to do, we'll see it in action also. You have to enable the OSPFv3 routing on the device using the command IPv6 router OSPF and then the process ID, just like in the case of the IPv4 also. Here also you have to give the process ID. Then assign a router ID with the command router ID and router ID. This is the most important part, critical part, because in OSPF v2, if you do not give router ID, it is okay, because okay means it takes the IP address of the highest interface, that is the serial interface, as the router ID. But in case of this IPv6, you have to definitely give the router ID, otherwise the OSPF process will not start at all, and it will give you an error that you must configure router ID. So this is essential, is vital. What is the step 3? Define the OSPF v3 interface with IPv6 OSPF, then process ID and area ID. So you have to define the process ID and then the area ID, like the area 0 or area 1. On each relevant interface, you have to go to each interface. And before that, you have to give the IPv6 enable command also, that I will show you. Step 4, verify the OSPF v3 configuration with commands like the show IPv6 OSPF neighbor, and definitely the show IPv6 root or the show IPv6 root OSPF. So this is a configuration of the OSPF and EIGRP. Unlike that OSPF also, it is even easier. You have to configure and enable the EIGRP protocol. And to begin the configuration, the protocol must first be enabled on the router. And this is done by entering the router configuration mode. You have to enter that and using the command IPv6 router EIGRP. And then you have to give the AS number. Like the OSPF, it is just like similar, where AS number is the autonomous system number. In the OSPF, we give that is the, let's say, the process ID, and here you give the AS number. Then define networks for EIGRP. You have to next define the networks that will participate in EIGRP by using the command IPv6 EIGRP and the AS number, and followed by the interface name. So it is like the OSPF, a bit different. Lot of similarity between these two to specify which interfaces will run EIGRP for IPv6. And you have to specify the interface number. Like, say, in the case of IPv4, what we do? We give the network command, but here we do not give that. You enter the IPv6 EIGRP and the AS number, and right there, you followed by the interface name and the interface. This step is crucial for ensuring that all relevant interfaces are included in the EIGRP process. Then you have to configure the EIGRP metrics if you want. Lastly, set up the metrics for EIGRP to determine the best path. For routing, metrics can be adjusted using commands such as, say, the metric weights to fine-tune the routing behavior based on bandwidth, delay, reliability, load, and MTU, this K5 value. So if you want, you can fine-tune it. So you want to load balance across the unequal cost paths, like that we know there is a variance feature. So for that, you can also fine-tune these metrics. Now, the common IPv6 routing issues we have to face, like common issues in IPv6 routing include, say, the misconfigured interfaces, incorrect routing protocols you have configured. Say you have configured one side OSPF, other side EIGRP or BGP, you haven't done the redistribution. Then address allocation errors, and these problems can lead to connectivity issues, packet loss, and network inefficiencies, definitely. So if this is happening, then how can you troubleshoot? What are the troubleshooting steps? So to troubleshoot these issues, network admins can verify interface configuration, check the routing table, and utilize dynamic commands like ping and traceroute. So in this case, the automation doesn't help that much, because nowadays people are talking about the automation, but to troubleshoot, you have to again go to the CLI. Then implementing best practices for IPv6 routing. What are those? Then effective IPv6 routing relies on several best practices that enhance network efficiency and security. Now we have to utilize the proper address planning, ensures optimal utilization of address space. Like, you have purchased an address space from the ISP and you do not know how to do the subnetting, how to allocate the address space, then definitely that is a wastage, and that is wastage for your time and money. Now you should avoid that, and you should select the right routing protocols, because it guarantees compatibility and performance issue. Regular monitoring of network performance is crucial to actually promptly identify and resolve issues for a robust environment. Now, the future of networking definitely lies with IPv6 routing and IPv6, because IPv4 is gone, almost is over, and the Cisco has officially announced the IPv6 that is supported on all of its devices. Now, IPv6 routing, it is crucial for accommodating the increasing number of devices and for enhancing the internet security. So as we transition from IPv4 and we embrace the IPv6, it ensures better scalability and efficiency in network operations. So we have covered this importance of IPv6 and the role of Cisco devices and configuration techniques. And I think that I have told you the theory part here in IPv6, everything, how to configure the IPv6, and what is the future of IPv6, what is the difference between IPv4 and IPv6. So all these things we have covered technically, the theoretically we have covered. But next we have to see the practical aspects. We have to do the practical configuration at least in one of the routing protocols, and I think OSPFv3 would be the best. So let's go for the configuration, and I have for you here GNS3 console, as you can see, because in packet tracer it is a bit problematic, or sometimes it gives some errors. So it is better to do it in more advanced simulators like the GNS3. We just switch on the routers and now go to the console. It is booting. Let's say the R1. So let it boot, and then we'll start the configuration. Yes. Go to config mode and first of all give IPv6 unicast routing. That is the command. Next, create a loopback interface and give the IPv6 address. Let's say it's 2001 and colon colon. You can give any address. I'm giving one, that slash 128, or you can specify 64 as well. And another loopback also you can create. I'm not creating now. And now go to the interface, say fastest 0 by 0 that we have here, and just give no shut. And I think it's already up, and it's up now. And IPv6 enable that you have to give. This is a very like the 2001, and let's say it's DB8. You can give any hex number 0, and then the subnet say it's 20 colon colon as we specify 1 slash 64, that is IPv6 prefix. And you go to the, say let's say the other interface if you have. Here I do not have any other interface. So here that is I think the configuration of the interfaces. And now you just go to the OSPF part. You, after configuring the loopback and the, say the fast ethernet port IP, then again you back to the exit, and then you go to the config mode and IPv6 router OSPF1. Now you have to pick one router ID, router, then ID, say 1.1.1.1, or you can pick any number, and then also you exit. If you do not specify router ID, the interface or OSPF will not be up. Now you go to any interface like loopback 0 if you want, and it's very important IPv6 OSPF 1 and the area ID 0, and also the interface fast ethernet. So this way you can configure the OSPFv3 on the routers. And you can follow the similar process here on R2 as well. So we'll go to the R2 now. Then you have to give the loopback. IPv6 address. Let's say 2001 colon colon 2 and slash 128. And also go to interface F0 by 0 and no shut. IPv6 enable. The same thing you have to do. IPv6 address. Let's say you want to give the address here is in the same subnet actually, that is 2001, and DB8 that we gave 0, 20 is a subnet, and colon colon 2 slash 64. And IPv6 router ID. Yes, it's done. So you can see the OSPF route. So I think that is the IPv6 process, and neighbor, you can see also neighbor is up. So this is the way you can configure the IPv6, and so that is it that I have shown you the practicals and the theory part. And also nice content is going on. I will share a form in the Google form. There are some questionnaires on this OSPF and the IPv6 and the routing as a whole. And you can definitely give the answer to these questions. And I urge everybody to actually attempt this questionnaire. And there are very few and very basic questions on this IPv6 and OSPF and EIGRP and BGP, and everybody should attempt it right now. And if you give the correct answer, say almost 8 questions there, definitely you will get a certificate on this. So everybody should attempt it right now. So that is about the IPv6 that I've shown you. I've shown you the theory part we have discussed, and also I've also done the practical part, that is on the OSPFv3. And similarly, you can also configure the, say, let's say the different devices, that is the EIGRP, also the BGP, because the process is same as we have seen. Also, that you have to only pick up a router ID. That is the one part that you have to remember, because if you forget to pick up the router ID, the OSPF or EIGRP, BGP, nothing will start. And also you have to do that IPv6 enable that I was showing you, that IPv6 enable. If you forget, definitely the interface will not be advertised, because it is like the network command. And also IPv6, OSPF, and the process ID and the area and the area number. Then you will have the neighbor relationship up that I have already shown you. So that is all about the IPv6 routing on the Cisco devices that I have for now. And I've already told you the theory part that will be very beneficial for your certification on the CCNA, also the CCNP Enterprise, that is the NRC and NCore both, because in NRC also it has OSPF 3, also in the NCore level it has OSPF 3 and the other protocols like the IPv6 also. So that is it, and I hope that you'll be able to configure this IPv6 routing in your enterprise network. Also, you have to be configuring this and you have to practice it well for your certification goals. So that is it from me today about IPv6 routing on Cisco devices now. I will come with a new topic next time. Till then, keep studying and bye.